are going to start with computer software. Now, if we are to look at the introduction of computer software, now remember in our previous lessons, as we are looking at computer hardware, we've said the computer hardware are the tangible parts of the computer. Now, when we talk about software, we can't touch software, though we can use them. So they are intangible. But if you're asked to define what a computer software is, that is not how you're supposed to define it. You'll have to tell us that computer software is a sequence of instructions that tell the computer to perform a specific task. Okay, the computer uses certain programs, certain instructions, lines of instructions that it can use to do what it does best. Okay, now these software are categorized in very, very many ways. We use these softwares every day as we're chatting, as we're even watching TV. Some of us have Android TVs at home now. You can install software, you can do anything so long as it's software. So the software is very, very important. Without the software, we wouldn't even be able to use the computers. They would be useless. Okay, so the computer software, like I said, is a series of electronic instructions, commands, or programs which tells the computer how to perform its tasks. So they are intangible. Okay, now these computer software are made of certain small data called programs. Okay, now you'll also be asked to define what a program is, a computer program. You have all been hearing that I've written there's a computer program which can do this and this and this. Okay, so if you're asked to define a computer program, you could say it is a complete sequence of instructions for data processing to be performed by a computer. Okay, so it is with the help of the program that data can be processed. Okay, data can be processed with the help of computer programs. All right, so what we have to know is that the software is subdivided into two categories. That is the application software and the system software. So we are going to look at these two categories into details, digging deep in seeing what other applications or what other softwares can we find in them. We shall look at them in details. Okay, as usual, after this session, I will advise us to come in for the second session just immediately. Yeah, so those are the two categories. Now we shall look at those categories, but before we look at those categories, let us look at what we call user interfaces. Now, in our daily lives of using these computers, we encounter interfaces. The interface actually is how you interact with the computer software. It provides you with a way in which you can actually talk to it or interact with it. So the term user interface is the way in which the computer presents itself to the user. The way you see your phone, the way you see things arranged on your screen is what we call a user interface. So there are two types of user interfaces. Okay, there's what we call the command line interface, and we have the graphical user interface. Looking at this one by one, the command line interface is much more complicated. What does it mean? It means you'll have to learn certain keywords. Okay, the command line user interface, the user has to type keywords or has to press some special keys on the keyboard to enter data. And these keys, when pressed, will be issuing instructions to the computer, telling the computer what to do. So like I told you, keywords, these keywords are known to be the way they are. For example, when you look at our screen here, I just took a screenshot of my command line interface. These are some of the keywords you can use in the CMD. Okay, these are some of the keywords you can use in CMD. I mean the command prompt of Windows. So the example of a command line interface could be the command, the CMD, or the command prompt of Windows operating system. So initially, we had an operating system called DOS, which was only command line. Okay, some of you who have heard about Linux operating systems initially were also command line. So this is how the interface looks like. You have to know certain keywords to make sure the computer does its work. So what do you think are the advantages of this computer? The command line interface. Now, first of all, the command line, because we are pressing information or we are sending instructions directly from the keyboard by just pressing, no need to process any other step to process this data, it becomes very fast because you're simply pressing a key or you're just typing a word directly from the keyboard. So processing or execution of these commands is going to be very, very fast. Okay, then it takes up little memory and normally does not even require a very fast processor. That is why in the very first operating system, the DOS, where it was command line, people were using DOS because they had weak computers compared to the computers we have nowadays. Okay? The computers nowadays are very strong. Using a command line interface only, for example, installing the DOS on your i5 with 8 GB RAM and some graphics card, you will be misusing the computer. You're not using the computer to its potential. But anyways, using an operating system depends on how this user perceives the operating system. It is about now user preferences. Okay, so when you are using this command line interface, they take up little memory in the computers. Okay, because they are not big. You are dealing with words only. You're just typing certain keywords, and these keywords need to be processed by the processor. Okay, no need to execute or to process a graphical image or something. Okay, everything is command line. If you want to copy a file, you'll have to write the commands. Okay, now many commands can be grouped together as a batch file. For example, if you're moving one file to another, if you're moving one file from one folder to another folder, you'll have to join a series of keywords. Okay, so the commands can be grouped together as a batch file so that repetitive tasks can be automated. You can actually say, after I'm done copying this, you can reboot the computer and you write all that information or all the command at once. Copy file A to folder A, to folder 1 and folder B, from folder 1 to folder B, and then reboot the computer after. If that is the kind of instruction you've put in this command line interface, it is going to be processed at once. No need for you to first copy and then you come back and also shut down or restart the computer. So many commands can be grouped together. Okay. Now, the one major disadvantage of the command line interface, it has to be learned and memorized. Now, up to now, I'm not sure if there's anyone in this world who remembers all the commands or all the keywords we use in the command line interfaces. Okay, but you'll have to memorize this. You just use them for doing whatever you want to do. Sometimes you'll even forget certain commands. You'll have to go back and read about them. So it requires you to memorize. It makes you to even make you to learn the language. So we therefore say that it is not, it's not user friendly. Okay, so that is the main disadvantage of the command line interface. Now, looking at the graphical user interface, remember the graphical user interface is the one we are using right now. Okay, we are using what we call the graphical user interfaces. Now here, with the graphical user interface, we find the user is using a lot of things to do its work, to perform its operations. Okay, we use menus, we use visual images such as icons, buttons, and other graphical objects to issue commands to the computer. If I'd wanted to open Visual Studio Code, all I have to do is go and click on that graphical representation, which is an icon on the desktop. Okay, here we have other icons. We can actually just open on it by clicking. So here you don't need to memorize keywords to make sure that you can actually perform your tasks. Okay, so that is the graphical user interface. Now, we're looking at the advantages of the graphical user interface. The graphical user interface is user-friendly. All you have to do is know where to click, know how to move from one page to another, know which icon represents what. Okay, it's easy to be learned by the users, and it's also very easy to work with. So there's also no need for you to type and memorize any command language. Okay, though some of us or some people prefer to use both of them at a go. That is why Windows comes with what we call the CMD, okay, the command prompt. It provides you with the other interface, the command line interface. That is if you want to use. But whatever you can do in the command line interface, you can do it in the graphical user interface, okay? So the interface is similar for any application. When you open Word, you know where to find the close button. When you open PowerPoint, you'll find that the close button is actually in the same place where the close button for Windows application is. So you'll find that the interface is similar for any application, okay? You find applications that are related, okay? You know where to minimize. Always when you want to minimize, you have to touch on the minus button on the left, on the right corner, on the right upper corner of the window, okay? You'll find that most of these applications have menus, and in most of them, the menu called file doesn't exist. I mean, doesn't miss, okay? So the interface is similar for any application. Now, if we look at the disadvantages of the graphical user interface, members, it requires more memory and a faster processor. Because we're running applications and graphical applications, these applications require space to run, okay? Every application you run, like I told you during our time when we are looking at the RAM, you will have to open a program that is going to be loaded onto the RAM. So these graphical user interfaces require more memory and a faster processor. So because we are dealing with huge things, the processor has to process for a little longer, and it has to go through certain steps, okay, which are more steps than what the graphical user, the client, what the command line interface will demand. Okay, so the processor has to be fast. Okay, now it occupies more disk space to hold all the files for the different functions. Now, if you are to install a game on your PC, these games, all the applications we need to install on our PCs, all the graphical user interfaces we need to install, normally come in what we call a folder. Now, the folder is going to consist of other folders, which is going to have some files, okay, which need to be installed. So these all have to contain they have to take some space in the memory, okay? So they occupy more disk space to hold all the files for the different functions. So each of those files we find in these folders is going to perform a certain function, okay? Therefore, they will occupy more space, okay? All right, now let's go to what we call the system software. Now, I told you in the beginning that the software, computer software, is divided into two parts, what we call the system software and the application software. And I also remember telling you that we are going to look at these into details, okay? Now let's look at the system software. What we looked at previously was just an introduction, okay? We have just been looking at an introduction which can be examined, okay? So don't look at it as an introduction to be ignored, okay? It was just taking us to where we are right now. Now, when we look at the system software, members, we need certain programs to make sure that the performance and the control of the computer system and its devices is enhanced, okay? Now, it is the work of the system softwares to make sure that the computer system and its devices and their performances can be controlled, okay? Can be controlled and can be made more efficient. Without the system software, we will find difficulties in using our computers. Now, the system software also serves as the interface between the user, the application, and the hardware, okay? So if you needed to use a mouse, you will need a system software to enable you to be able to use this mouse, okay? Because when you connect the mouse to the computer, it has to load a certain program which is supposed to be processed by the computer processor such that it can be used. If you are using a projector or a scanner and you've connected this scanner to your computer, your laptop, you will be asked to install certain programs. What are these programs? We call them drivers, okay? You have to install these drivers onto your computer in order for you to be able to use the application, okay? So the system softwares are very, very important. They are so important that without them, it would be hard for us to use the computer, okay? Now, there are mainly 3 types of the system software. We look at the operating system. We look at the operating system, which is the main system software we have to look at. Now, we also have what we call service or utility programs, or we can also just call them system utilities. And then we have what we call programming languages. We are going to look at these one by one to understand them even more, okay? Now, moving on, starting with what we call the operating system. Now, members, the operating system is the master control program. It's the most important program in a computer. So without the operating system, all the other systems cannot be used. Your application systems and other systems have to be used. They have to be used on the operating system. So that's why every time you receive a computer, you have to know which operating system you are using. Now we have this operating system. There's several of them, but we shall look at them one by one. So when you look at this image is telling you how powerful the operating system is. It is in control of how the applications in the computer run. It manages the hard drive. It is also in charge of managing these printing devices, the keyboard, the peripherals, and so on. So the operating system is very, very important. However, we classify the operating systems in these types we're going to look at. Okay, we have what we call the real-time operating systems. Now, what do you think are the real-time operating systems? When we talk about real-time operating system, the definition actually comes from the word real-time. Okay, it is a multitasking operating system that aims at executing real-time applications. We have real-time applications. Okay, your WhatsApp, the WhatsApp you use for chatting and so on, is a real-time application. Okay, the Facebook we all visit is a real-time application. So there has to be an operating system whose aim is supposed to be executing these real-time applications. Okay, now we also have what we call distributed operating systems. Now, members, when we sit in a place or in excuse me, in a computer lab, we have several computers. Imagine these computers were all independent in the sense that each computer runs on its own. Now, a distributed operating system is the one that is going to manage the group of independent computers we're talking about. So it makes it appear as if it is a single computer which is being used. So the operating system, its work is to make sure that a group of independent computers appear as if it's a single computer. So it manages distributed independent computers, okay, at once. So when someone looks at this operating system, it's as if the person is looking at one operating system. Then we have what we call embedded systems. Now we have several machines at home. We have cookers. These cookers that use electricity. Excuse me. We have microwaves. We have which other example could I give? We have washing machines at home. All these need an operating system to perform its work. Now, the kind of operating system we use in such devices is what we call an embedded system. Okay, it's an embedded system. The operating system is designed for being used in embedded computer system, also known as embedded operating systems. Okay. Now, the examples of some of these systems I've already told you, because when you're dealing with some of these devices I just mentioned, you'll actually see that there's a small screen on which you can input some some instructions to be performed. If you are using a microwave, there's a screen where you have to adjust the temperature and do something. So the kind of operating system that is managing this type of programs or the instructions you're supposed to send to the computer is what we call the embedded operating system. Now, we have what we call the single user operating systems. Just like the name suggests, it's a single user operating system. Now here, it only allows one user to run one program at a time, okay? You can't have two users using the operating system at once. So the single user operating system will allow a user to use it at a time, okay? The examples here we can look at is the DOS. The DOS stands for Disk Operating System, the command line, okay? In the command line, you'll only need to use one user has to use the DOS at a time, okay? So can't the microwaves also fall in real-life operating systems? No. Why do I say no? Some of the examples of the real-life operating system, I already told you the kind of applications, because we say the real-life operating system is responsible for managing real-life applications, okay? Real-life applications. Unless you don't know what a real-life application is, you can't understand how the real-life operating system works. I gave you examples of applications that show that, for example, someone is online right now. You are using Facebook, and when you look at your chat list, a green dot on your users are going to show you that this person is online right now. That shows that it's a real life application, okay? So I see the Gracious, your hand is up. You can ask your question. The Gracious, unmute and ask your question. The Gracious, okay. I think he, okay. All right. Now, our time is almost running out. So when we talk about the real life applications, we can also sometimes call them real world applications, okay? So they are the ones that manage, the operating systems that manage these real life applications are the ones we talked about as real life operating systems, okay? All right. Now let's move on. We also have what we call multi-user operating systems. Now, in the previous one, we looked at the single-use operating system, where we said one user uses the operating system at a time. Now, when we talk about multi-user operating systems, we can have as many as more than 3 users that are using the operating system at the same time, okay? You can have a user running whose account is open in Windows, but you can also open, if another user can come and access the same computer without logging off, without also shutting down, without closing the other user. So that means two people are using the operating system at a go, okay? 2 or more people. So multi-user operating systems allow 1 or more users to run programs at once or at different times, okay? Then we also have what we call multitasking operating systems. Multitasking, when we talk about tasking, it is something the computer is doing at a specific time. When we look at operating systems like Windows and Linux, okay, these operating systems allows one user to work on 2 or more applications that reside in the memory at the same time, okay? You can open your VLC or your virtual DJ. As you're playing music, you're doing coursework or you're doing your homework, okay? As you're doing other things, you can be playing your games as you're actually listening to some music. Okay, that is what we call multitasking, performing different tasks at the same time. Okay, all right, I see someone is saying, okay, the gracious is saying, I should say something about the operating system. Okay, let me finish these other types and then I go back to the embedded operating systems. Now, we also have what we call multiprocessing operating systems. Now, for multiprocessing, these ones can allow or can support 2 or more CPUs running programs at the same time. Now, you've heard of when we look at operating systems members in our computers nowadays, you can find a computer that has 2 operating systems. 2 microprocessors. Okay, for processing. For example, I can talk about the CPU and the GPU. These 2 can be processing at the same time. As you're playing a game and you've left something moving on, remember the CPU is the brain, okay? But the CPU is a microprocessor, and so is a GPU. So when we see two processors processing data at the same time, we call that multiprocessing. Now, let's go back and look at the embedded system for Deogracias to understand. Now, Deogracias, an embedded operating system is actually a specialized operating system designed to do what? The operating system is designed to perform a specific task for a device that is not a computer. Okay? Why do we say for a device that is not a computer? We are looking at examples of this operating system, of these devices. We gave the washing machines, even the photocopiers. When you look at the photocopier in Mr. Mweru's office, that big photocopier, it is also having an operating system. But this operating system, the photocopy is not a printer. It is an embedded system. So it has to run an operating system which manages how it does its work. So when you go there to photocopy your work, you give him your papers, you tell him, please provide me with about 2 copies. He has to enter that instruction into the machine, but through a small window, a small screen, where he touches and he configures the instructions. That operating system which is managing, he can't configure those things without an operating system managing these things. Okay, so the instructions is going to send are supposed to be processed or are supposed to be managed by this embedded operating system. So the photocopier you see in Mr. Mweru's office is an example of an embedded device. Okay, an embedded system. Okay, so in other words, you can say that an embedded system is actually a small computer that can support another machine which is not the computers we know. Okay, I know it's kind of confusing, but you just have to understand it in terms of the examples. Okay, so I hope it is okay, Deogracias. Okay, so now let's move on. After this other slide, we are going to log off and then we are going to join in for the second session immediately after this, because we are only left with about 2 minutes. So the kind of the operating systems we have in the world nowadays, there are so many. Okay, in our daily lives we use these operating systems. Some computers even use 2 operating systems. 2 operating systems that they go, what we call dual booting. Okay, so now some of these examples, we have operating systems we're using every time. Like some of the examples we use every time, we have the Android, we have NetWare, we have Unix or Linux. Most of us use Windows. We have Windows 7, Windows Vista, Windows 8, the Mac OS, Palm OS, Windows CE. Some people are still using Windows XP Professional. So we have several of these operating systems. What are the functions of the operating system? We said the operating system is the main. Okay, Nsubuga, unmute and ask your question, please. Isaac, I see your hand is up.
Yes, my question is, the question is, if you have like an Android phone, Android phone,
yes,
can you download or use change to iOS? Can you change the operating systems in the different gadgets?
Okay, that is a good question. The answer to that is a no for a phone. Okay, the phones, you see now, it also happens that the operating systems running on our phones are being produced mostly by the people who run those, who operate those operating systems, who design the operating system. Android phones are meant to run Android only. However, we have what we call launchers. There are devices we call launchers, programs we call launchers that can actually help you mimic. It can help you mimic another different operating system on your phone. So I can be running an Android operating system, but I can download a launcher that is for Ubuntu. It can even download a launcher for Windows applications. So it will appear as if you are using Windows operating system on your phone, and yet you are simply using a program that mimics how the operating system is. But to update to change your operating system on a phone is impossible. Okay? It's impossible. That is why we have before they started producing Nokia Android phones.
Pardon? Sir, pardon.
Okay. This is how it happens. A phone which is Android remains Android. There's no way you can change it to run a different operating system like iOS. Okay, but we have programs that are called launchers. Several of them, you can even find them on Google Play Store. You can look for a launcher for Linux. You can look for a launcher for Windows. You can look for a launcher for iOS. But when you put these launchers on your phones and you run them, it's going to make your phone appear as if it is actually running an iOS operating system, or as if it's running a Windows operating system, and yet it is still running Android. Okay, so Android operating systems in phones cannot be changed, but you can install certain programs to mimic another operating system, as if it will appear to someone as if you're running these. For you to understand this more, I don't know if you have ever used any launcher. You can go ahead on Google Play Store at your own free time, look for a launcher, any launcher for any operating system, and when you install it, and you'll actually see that your phone is going to change the appearance. The interface is going to start looking like for an iOS phone. Okay, but it is not possible to change from one operating system on a phone to the other. I hope I've helped you. I hope I've helped you. Okay, I know there are people who, someone is saying there are people who want to use iOS. All right, Jojo, please ask your question.
Yes.
Yes, please. Yes, Jojo.
I was asking what you call like the term used for ratings on one computer.
What term is used for? I can't
like
get you.
When two operating systems run one computer.
Okay, we call it dual booting. The word boot put together with dual. Dual means two, not so. So two operating systems running on the same computer is what we call dual booting. Okay. So, Boga Isaac, you still have something to say?
Yes, teacher. My other question is, the different operating systems have like advantages over the other. That if I'm using this one, there are things that I enjoy, there are things that I can't access.
Yes.
That someone with this kind of operating system can't access.
Yes.
Are there such advantages?
Yes, there are so many of them, but all of these depend on actually your preference. Now, you see someone who is using Android is very comfortable using Android. But when you look at the way Android works compared to the way iOS works, the two are different. You'll actually notice that, first of all, because these two are running different operating systems, you can't share certain files between them. You can't run a program which is running on iOS on an Android operating system. It has to be a version which is supported by Android. So the advantages you enjoy over Android are there. However, someone who is running iOS, someone who's using an iOS phone is also enjoying certain advantages, okay? For example, people who use iOS in iPhones, these people enjoy security more than people who are running Android. The security implemented in iOS, in the iPhones, is more compared to the one we have on Android. So such advantages exist, but depending on where you're comfortable, you use anything you want, okay? So it is good to explore though. It's good to explore. You can try, if you have the money, you can buy an Android phone and iOS, and then you see which one is better for you. Okay, so Jojo, you still have more? Okay, so there are no more questions. Now we can continue. Now let's look at the functions of the operating system. The operating system is very, very important, members. First of all, it provides an interface between the user and the computer. The programs we are running on our computers, without the operating system, we can't use them, okay? We can't use them without the operating system. So the operating system is very, very important in providing us with an interface to use this. When we install Windows, you'll see that the interface you see on Windows is not the same interface you see on your Android phone. The interface we see in iOS or Macintosh is not the same interface you see in Ubuntu or Kali, okay? Ubuntu and Kali are Linux distribution, Linux operating systems, they fall under Linux. Okay, so these provide us with interfaces, but the interfaces are very good to help the users actually interact with the computers. Okay, that is one advantage. Now, when we are using the computer, there is always constant information flow. Information is flowing constantly from the keyboard, from the mouse, from the monitors, and so on. Excuse me, my network is kind of okay, from the parity CPUs and so on. Now, the information flow in computers is managed by the operating system. It is responsible for these information, how they move in the computer. Then the operating system also keeps record of the saved files. Whenever you save a file in your computer, you'll actually see that you are able to see the name of the file you've saved it with, the size of the file, and even the location where you can find it. All of these are provided, functionalities provided by the operating system. Okay, so without the operating system, we can't be able to know where this file is if the operating system doesn't show us the locations and so on. Okay, so we have to understand that. Now, the operating system is very, very important in establishing relationships between hardware and software. Now, the program which is running to enable us to use the microphones on the phones or the speakers on our computers, those programs have to be directly linked to the hardware they are supposed to run. Without the operating system, we can't actually know which program is for which. It is the operating system to identify that now this program is meant to help us use the mouse on the computer. So it is the work of the operating system to establish this relationship between this program and the hardware. Okay. Then it also controls the running of other programs. All the programs running on the computer are being managed by the operating system. Okay. Then the use of peripherals, like I told you, the mouse is also work of the operating system. Organizing the use of memory, or what we call memory management. Now, when you're saving your work on the computer memory, it is the work of the operating system to actually allocate space, first of all, on this memory where you can save. It manages memory. How? There's what we call fragmentation. Okay, when we are saving, look at the memory of a computer as if it was a block, like it was made up of blocks. But there are times when you are saving your work, it actually saves after a certain block has not been occupied by memory. Now, the operating system has to know that now the memory is being misused. So it is its work to make sure that all the blocks are filled at a time. All the blocks in the memory are filled at a time. So it manages memory. How you save information on your work or your work on your PC or your computers is being managed by the operating system. How information is being loaded from the hard disk to be placed on the RAM for execution is being managed by the operating system. Now, when we are starting our computer, the moment you press your button, your power button in the computer, pop, and then your computer starts running, the booting process is actually enhanced by the operating system. Okay. First of all, we can't use the computer if there's no operating system. So the operating system being available helps us in the booting process. We call the booting process a process which is completely and successfully completed because we are now able to use the computer at some point. Okay. So without the operating system being present in the computer, actually the booting wouldn't complete. So the booting process is complete with the help of the operating system. Then in file management, we also use the operating system. It tells you where to put your files. It helps you even organize your files in certain orders. You can sort your files in ascending or descending order by date, by names, or by type. Okay, all this is the work of the operating system. So these are the functions. These are some of the functions of the operating system that you must be having at your fingertips or in your heads. Okay. This is what the operating system does. There are several others. For example, the operating system is also in charge of scheduling work on a computer. When you're trying to for example, print work, that scheduling, like you want, okay, let's use Zoom as an example. On Zoom, before we use Zoom, I actually schedule a meeting. There seems to be a relationship between user interface and an operating system. The relationship between the two is the user interfaces are found in the operating system. Each operating system comes with a user interface. I hope you are clear. Each operating system comes with a user interface. The disk operating system comes with a command line interface. Windows 8 operating system comes with its own graphical interface. Even Windows 10 comes with its own graphical interface. So the relationship is the user interfaces are embedded. They are found within the operating system. They are part of the operating system. Okay. All right. So talking about the scheduling, we actually schedule for a meeting before we come for the class. So that scheduling bit of it is managed by the operating system. The operating system knows that within the next 2 minutes, we are going to start a lesson. So it is the one which is helping us schedule. Okay, that is another function. It helps us in scheduling. Okay. Sometimes also the operating system helps us in many other things. For example, if your computer is going to crash when you're running a program, you'll actually receive a notification or a dialog box telling you that this program might be dangerous for you to run. Okay, because the operating system has identified certain problems where they might affect the computer. Okay, so those are the different. There are so many, but these are the few you can keep in mind. If you have more, you can actually add on to this. Okay, now moving on to the next. Now let's look at what we call programming languages. Now, when we look at a language in general, it's actually a medium of communication between two human beings, or in this case, between two or more computers. Now, we are able to communicate right now because there is a level of understanding. I am using a language you can understand. The same thing happens to the computer. when you are using a computer or you want a computer to do something, give it something it can actually understand, okay? However, where we are right now, we have certain things that can help us actually convert from one language to another. If I was teaching people who don't speak English, probably I'm teaching people who speak French, I would look for a program that can help me translate from English to French. Okay, so that program will be getting my words and converting them to the French you people can understand. That is an example. So that kind of program is what we call language. Okay, someone is asking a question. Okay, all right. So we have to understand, we saw what a program is. Okay, we saw what a program is. We said it's a logical arranged set of instructions that can direct the computer on what to do, or that allows the computer to do what it's supposed to do. Okay, that's what we call a program. So when we are dealing with programming languages, actually we come up with certain instructions we write on what we call editors to make sure the computer does what it's supposed to do. For example, the program that would help us translate my English language to your French language you understand is what we call a set of instructions which will be written by someone, that when you hear the word go, G-O, when you hear it, please translate it to this. Letter A is translated. So that instruction which is supposed to do that translation is what we call, when we put all those instructions together, is what we call a program. Okay. Then we also look at programming. The process, the steps you take. There are several steps you take for creating computer instructions. Or there are certain languages, what we call programming languages, which are the software programs used by programmers to write computer software instructions, are what we call programming languages. We use these programming languages for programming, okay? Now, whenever you sit down, you have to first of all select which programming language to use. I can sit down and be like, okay, I want to come up with this translator, but using a programming language called C or C++ or COBOL, okay? So when you come up with a programming language, you sit down, get an editor, and you start writing your code, or you start programming, okay? So you'll be asked what a programming language is. Most of the times, you'll have to, of course, tell us what it is. Software programs that are used by programmers to write computer software instructions. Now, if we are programming, someone who has sat down to write computer software instructions is what we call a programmer. Okay, don't just sit there and you start writing words and then you call yourself a programmer. You must be having the knowledge to do this. Okay, so when you have the knowledge and you sit down, you come up with a program that can actually perform a certain task, then you are a programmer. Okay, that is a person who writes a program. Now let's look at tools used in programming. When we're programming, members, we don't just sit and you start writing in any editor and be like, okay. We need the help of certain tools. Okay, we have what we call debuggers. Debuggers are those programs which help us identify, they help us detect, they help us locate or even remove the errors. Now, these errors can be syntax errors or logical errors. When we talk about syntax errors are to do with how you've written the instruction. For example, if you write a keyword and you omit it somehow, it's going to be a syntax error. When we talk about the logical errors, the how this instruction is supposed to do something, if it doesn't make sense and yet your syntax is correct, it's going to generate what we call a logical error. But how do we find these errors? We use a tool called debuggers. The debuggers help us identify or to detect these errors. After finding these errors, we can actually now either correct them or remove them. That brings us to what we call debugging. So the process of removing these errors or the process of rectifying these errors in a computer program is what we call debugging. And therefore, a bug, because when you debug something, when you detooth it means you are removing a tooth. When you're debugging, it means you're removing a bug. So that means a bug is an error, okay? Because when I'm debugging, I'm removing something, I'm removing a bug. I am rectifying a bug. That means a bug is what we are calling an error in this sense. So a bug is my network is kind of unstable. My network is kind of unstable, but I hope we're okay. Okay, so we have said what we now know what a bug is. Okay, then we also have a tool called linkers. The linkers enable calculation of any function in a program. Okay, then we have editors. Editors are the environment we use. The environment we use to create these program text files. Okay, they facilitate the creation, the editing, and formatting of the computer program text files. These editors are very important in the sense that without them, it would be somehow hard for us to write these programs in order to run them. So examples of these editors may include the Visual Studio Code, Sublime Text. We also have, there's so many. Notepad, the notepad you have in your Windows operating systems is also there. Okay. In Linux operating systems, we have what we call Vim. Okay. We have Vim. Okay. So these are programs. So what are the categories of the programming languages? When we are programming, we have to know, we have to understand. Okay, we have to understand the different categories. Okay, we need to understand the different categories of programming languages. I'm just going to add an image to what we have here so that we can see a graphical representation of these programming languages being classified. Okay. Okay. So I hope you can all see the image I've just added. Programming languages are categorized into two main parts. Okay. We categorize them into two main parts. Up there we have the programming language. Now it's divided into what we call the low-level languages and the high-level languages. Okay. Now the low-level languages may include the machine language and the assembly language. We are going to look at these languages one by one until we understand them. We also have what we call the general purpose under the high level and the specific purpose under high level still. The general purpose is supposed to do something general. The specific is supposed to do something specific. So we also have what we call the fourth generation languages, the fifth generation languages. We are going to look at these. You shouldn't worry. You will understand them by the end of the lesson. Okay. Now let's look at what we call the low-level languages. Now, these languages normally they provide basic computer languages. Okay, they represent basic computer languages. Okay, so what we must understand is that these low-level languages normally deal directly with the computer memories in our computer. They are directly connected to the computer memories. We are dealing with the computer at its basic level, okay, of understanding. Here we don't use words the humans can understand easily unless you study. The computer actually makes use of what we call the ones and zeros, okay? The ones and zeros in these low-level languages. The very basic language the computer uses is what we call the low-level language. Now, these are divided into mainly two, like I told you. We have what we call the machine language. Now, in the machine language, we're talking about how the computer actually represents its data. And here we say it represents its data in forms of on and off, meaning 0, or 1 and 0. So it uses binary digits to represent data at its memory. That is the machine language. Meaning if I'm to save the word machine, I have to convert that to what? To binary bits, binary digits, in order for the computer to understand. Okay. Then we also have what we call the assembly language. Now, for the assembly language is a low-level language that allows the programmer to actually use abbreviations or easily remembered words instead of binary code. Now, to represent certain words, for example, if I want to multiply whatever is in the variable called the A by whatever is in the variable called the B, I would use a word multi. Okay. Now, these words are also what we call keywords. These words need to be understood by the computer. Okay. So, the word store, STO, is supposed to help me store. So div is supposed to help me divide. So in assembly language, we use this abbreviation. Now you'll actually notice that the abbreviations we're using here, the short words we're using here, can easily be understood by us to some level. However, in the machine language, we can't understand 1 0 1 0 everywhere, 0 1 1 0 1 1. You see all of them there, and it's kind of confusing. So it is only the computer that understands this language. Then if we're to look at the characteristics of the machine codes, you'll actually see that they can be used directly with the computer without interpretation. If you can write in the computer language, why would you need something to translate it? Because later on we shall see that in order for the computer to do whatever we have programmed in these programs to perform a specific task, it must be converted to these languages, or the words we understand, to what the computer can understand. But if you're a human being and you can write in the machine language, why would you need something to translate? You don't need anything to translate what you can tell the computer to do. So at this level of language, the computer can directly execute the code without interpretation. Okay. Then they are also machine or computer dependent. They depend on the computer, not on the human beings. Okay. They depend on the computer. Now, because we cannot easily understand them, we can say they are not user friendly. You cannot learn it easily. Though there are people who learn machine language. Actually, when you reach campus and you've taken a course connected to computer, you'll actually see some machine learning there, machine coding. Okay, but it will not be easy for you to learn. Okay, because even learning the high-level languages is still hard. Now, when you take yourself lower to the machine language, it will even be harder for us to learn. So they are not user-friendly. Those are the three main characteristics you can give for low-level machine languages. We also call them the first generation languages. Then the assembly language is second generation. Now, when you compare the two, you'll actually see that it is easier to understand the assembly language compared to machine language because it is a second generation. Okay. Now, if we are to move on, we also have what we call third generation languages. This is the beginning of the high-level languages. Okay. The examples of these high generation languages include COBOL, BASIC, Pascal, C, Fortran, and Pascal and Fortran. Okay, they are third generation. Are we together? So these ones can easily be understood slightly by the human beings compared to both the high level, the assembly language and the machine language. Then when we look at the fourth generation, which was developed in the early 1970s, okay, by different programmers, this is now where actually we have to indulge in giving out the words the human beings can understand. So here we see very high level non-procedural languages or rapid application development tools where programs are written by only telling the computer what to do as opposed to step-by-step process.